Okay, hey, it's me again. Let's go over the multiple choice questions on this, and I'll draw out anything we need to. Number one, projectile accelerates in the vertical direction, accelerates in the horizontal direction, accelerates both vertically and horizontally, or D, does not accelerate. Remember, projectiles accelerate in the vertical direction. As that thing's moving up, the speed upward or downward changes because of the pull of gravity, but the speed side to side does not. And we said picture the shadow going across the ground, that's my x speed. There's no acceleration in the horizontal direction, just in the vertical where it changes. So number one should be A. Number two, the best angle to launch a projectile if we want to go as far as possible, ignoring air resistance, is C, a 45-degree angle. Okay? And we talked about how that maximizes the x and y components because sine of 45 and cosine of 45 are both equal to each other. Number three, an arrow which is shot at a 35-degree angle will travel the exact same distance as an arrow which is shot the same speed but at a 55-degree angle. That should be true. We talked about that as well, that if I have something at a 45-degree angle, that it's going to travel a certain distance. And any angle amount I tilt upward, it should go higher, but not as far. And any angle lower, let's say I go, here is 55 degrees like we did in the example, and let's go one that's 35 degrees. It's not going to go as high, but it has more forward speed. Even though it's not in the air as long, it goes to about the same place as the 55. Okay? The reason why is because the sine of 55, remember we're doing our components of our speed vectors. There they are. Sine of 55 is the same as cosine of 35. And the sine of 35 is the same as cosine of 55. Okay, so we end up getting the same ratio of those components to each other and end up getting the same distance out when it does that. Number four, a projectile is launched at 30 meters per second at a 45-degree angle. When the projectile hits the ground, ignoring air resistance, speed of the projectile will be exactly 30. So if I shoot it up at 30 going this way, it comes down at 30 this way. If I shoot at a 45-degree angle this way, it comes down at a 45-degree angle that way. Okay, those are always consistent. That is ignoring air resistance, however. Okay. Number five, ignoring air resistance, the projectile in the question above will hit the ground at, we just said that, it's going to be exactly 45 degrees again, so that should be C. Number six, if we consider air resistance, in other words, do not ignore air resistance, the projectile should hit the ground at an angle, and that should be greater than 45 degrees. So if there is air, it does slow down just slightly in the x direction. Okay? An arrow might not, but boy, a soccer ball or a football, and you can even see that in football games, where the ball is kicked this way, and it looks like it comes down almost straight down by the time it gets over. The angle is not the same. So if we shoot this thing, here's its ideal path with no air. If I do it with air resistance, it's going to go up about the same, but it's going to start to slow down, and it's end up going to come and go not as far, and now the angle it hits is steeper than it would have been out here. Okay, so it hits at an angle. It's a little steeper, greater than 45 degrees if this was initially 45. No air resistance, leaves at 45, hits at 45. With air resistance, like I said, the football kickoff. It goes pretty flat here, it gets up to a certain height, but then it kind of slows down and falls pretty straight, not pretty straight down, but closer to straight down than previously. Number seven, a boat going across the river. The river is flowing. I've got a boat trying to go across. Let's make it really easy numbers. There's my river. The water is going this way at 5 meters per second. Let's say my boat's trying to go this way at 5 meters per second. Which way is the boat really going to go? It's going to go this direction. And if I'm standing over here with a radar gun, and I say, what's that speed? How would I calculate that? Okay. Again, looking at this, if I move this into a head-to-tail diagram, instead of a point diagram, you can easily see my 5 meters per second here. Then I'm going to do Pythagorean theorem and say 5 squared plus 5 squared should equal x squared, or that resultant, the real speed that it goes, is my x squared in this. This is 25 and 25, I get 50 equals x squared. I don't know the square root of 50, but I know the square root of 49 is 7. So this is going to be about 7.1 should equal x. So my true speed is 7.1 meters per second at an angle this way. when my boat is moving and when the river's going. Those two things add up and we get a speed greater than either of the two components. Number 8, the horizontal component of a projectile's velocity is independent of A, the vertical component. We talked about that in that earlier one. Okay? They don't affect each other at all. And the only thing that is the same would be time. Okay, so time for the horizontal and time for the vertical is the same. That's why we always find time first. We find it on one side, we plug it in on the other side. Okay, but horizontal and vertical components don't affect each other at all. It's like the old roadrunner going off the cliff, or coyote goes off the cliff and then all of a sudden he doesn't fall till later. That doesn't happen. As soon as he leaves the cliff, he starts falling. Gravity doesn't care that the coyote's moving forward. You say, well, if that thing's moving really fast, when does gravity take an effect on it? Well, immediately. Okay, there isn't any like delay time or anything like that. Number 9, projectiles are things that travel through air. An example would be a rocket using its fuel to travel in a curved path up and back to Earth. No, if it's using its fuel, it's not a projectile. It has another force. Remember, projectiles are things that are moving through space. Sometimes we say through air, but it doesn't have to be air. But here on Earth, moving through the air, and influenced only by the effect of gravity. Okay, so it can't have its own engine, it can't have its own propeller, it can't have its own wings and things. And then number 10, I ask you some of those. Circle the items below that are projectiles. Airplane, no, it's got a motor. A baseball, once I throw it, yes, baseball is a projectile, what's in the air. Golf ball moving through the air, yes, is a projectile. Bird flying, no, it's flapping its wings, it's not a projectile. It does not follow that path. Dead bird falling, yes, it's only under the influence of gravity. A cannonball moving through air, yes, cannonball does not have its own engine or motor, so it is a projectile. A car that drives off of a cliff, yes, is a projectile. Okay? It's moving through air and just falling as it's still moving forward. A diver before she hits the water. So if somebody jumps off a diving board or a platform while they're falling are projectiles. I shoot a basketball, that's a projectile once it's in the air. And a helicopter, of course, is not a projectile until it runs out of gas or something, and then it would fall and be a projectile. So, any questions on that? See me before the quiz on Friday. I will be here Friday. For sure. We'll take 5 or 10 minutes before we take the small test. It will not be a big test. These 10 questions should show up on it. Calculations like these 3 from the other videos should show up on it, and you should do just fine. Okay, but we can go over anything we need to before the quiz / test Friday morning.